Hey, hey you, hey, hey, you, hey, 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 yes, you, yeah, yes, you. It looks like you're answering permutation combination probability. Do you need some help? Huh? Oh, I see. Okay, I'll help you. Yes. Be a piece of cake for haha. Well. Before I show you how to answer, I will tell you what are permutation and combinations. So what exactly is permutation and how is it different from a combination? Permutation is associated with arranging things in different order. Combinations is simply concerned about combining things. For permutation, the order matters, but for combination, the order does not matter. Well, I'll show you an example. Here, we have three letters, A and B and C. We could arrange them. Example, C, A, B. Now, even though we have the same letters, their order is different. So these are two different permutation. The number of permutation is 2, however the number of combination is 1. These are considered 1 in terms of combination. In terms of permutation, these are considered two separate things. Just understand that permutation, the order matters, while combination does not matter. Now, another example. We have A, B, C, and D. Now, let's choose 2 of the 4 letters. In how many different ways can we arrange 2 of the 4 letters? And also, how many ways can we combine 2 of 4 letters? Now, let's make a list and use that to determine the number of permutation and combination of choosing a 2 out of the 4 letters. After that, I will show you how to use an equation to get that same answer. Now we can choose AB, we can choose AC, we can choose AD, we can choose BA, we can choose BC, BD, CA, we can choose CB, CD, DA, DB, DC. A total of 12 different ways we can arrange 2 out of 4 letters. So, the number of permutation in this example is equal to 12. Now, what about the combinations? So in combination, the orders does not matter. So, take a look back at A, B, and BA. In terms of permutation, these are two separate things. But for combination, you combine them the same letters. And since the order does not matter for combination, they're counted as one combination. If we count AB, we cannot count BA. So, if we're gonna count, let's say, AC, we cannot count CA. If we're gonna count AD, we have to eliminate DA. If we're gonna use BC, we're gonna get rid of CB. If we're gonna use BD, we can't use DB. And finally, if we're gonna use CD, we gotta get rid of DC. So, notice that the number of combination are equal to 6. 1, 2, 3, 4, 5, and 6. So now, you can clearly see the difference between the permutation and combination. So just remember, the permutation in the order matters, while combination the order does not matter. Now, how can we calculate these answers? Is there an easy way in which we can find the value as opposed to making a list of different possibilities? First equation you need to know is NPR. This helps you calculate the permutations. Now, these 4 letters, and we're choosing 2, so it's gonna be 4P2, and we're choosing 2 out of group of 4. Now, the equation of NPR is equal to n factorial divided by n minus r factorial. In this case, we can see that n is 4 and r is 2. So, n minus r, that's gonna be 4 minus 2. Now, 4 minus 2 is 2. So we have 4 factorial divided by 2 factorial. So, what exactly is 4 factorial? 4 factorial is 4 times 3 times 2 times 1. You start with number 4 and you multiply every integer all the way to 1. 2 factorial is simply 2 times 1. So, we can cancel 2 times 1 and we're left with 4 times 3. And we know that 4 times 3 is equal to 12, which is we have here. Now, how can we calculate the combination? What is the formula that we can use? N CR is equal to N factorial divided by N minus R factorial divided by R factorial. So, basically, in terms of permutation, a combination is equal to NPR divided by R factorial. This portion right here is NPR and divided by R. So, we have 4C2 in this example. So, N is 4 and R is 2. So, this is equivalent to 4 factorial divided by 2 factorial times 2 factorial. And we know that 4 factorial is times 4 times 3 times 2 times 1. 2 factorial is 2 times 1 and we have another 2 factorial. It turns out that 2 times 2 is 4. So we can cancel those 2 with a 4 on top. We'll ignore 1 because 1 times anything won't change a value. So, what we have left is 3 times 2. 3 times 2 is equals to 6. And now, you understand the equation and also how to make lists to determine the number of permutations and combinations. My friend, I've helped you. Now, it's time to answer your assignments. It's a pleasure to help you. I've got to go. I still have a lot of monkey to help. Ciao.
Wow, what a weird dream. I just know how to answer permutation and combination. Huh. Yes, this is it. Now. Yes, this is the answer. Huh. Yes.
That's all, folks.